In this video, I'm going to talk to you about exponents. Let's begin with just a simple exponent, 3 to the second. This exponent means 3 times 3. We say that 3 is the base and the 2 is the exponent. The exponent tells us how many times to multiply the base by itself. 3 to the second equals 3 times 3. The answer is 9. 3 to the fourth would say, take the base, which is 3, and multiply it by itself 4 times. 1, 2, 3, 4. 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the fourth equals 81. Numbers without an exponent, let's say just 3 by itself, can always be written with an exponent of 1. So 3 to the first power just means multiply 3 by itself 1 time, in this case, just 3. So there's some rules that we have for working with exponents that generally relate to multiplying and dividing exponents. I'm going to focus on the rules for multiplying exponents in this video, and in the next video I'm going to talk about some rules for dividing with exponents. So let's start with just an example. Let's say you had 3 to the second and you wanted to multiply it by 3 to the third. Well, 3 to the second is 3 times 3, and 3 to the third is 3 times 3 times 3. So the answer that we get is 3 to the fifth, because we have 1, 2, 3, 4, 5 threes being multiplied by each other. How about 2 to the third times 2 to the fifth? Well, the same thing happens. 2 to the third is 2 times 2 times 2. And 2 to the fifth is 2 times 2 times 2 times 2 times 2. And so we end up with 3 2's and 5 2's, 8 2's being multiplied. So our answer is 2 to the 8th. Can you think of a simpler way that we could have done this? Well, if we had just taken the two exponents and added them together, we would have gotten the same answer. 2 to the third times 2 to the 5 is 2 to the 8th. This is only true when we have two numbers with the same base. It doesn't follow that if I had 2 to the third times 3 to the fourth, that I would have 6 to the seventh, although that might be a common wrong answer. Let's think about why that's not true. 2 to the third means 2 times 2 times 2, and 3 to the fourth means 3 times 3 times 3 times 3. But 6 to the seventh is 6 times 6 times 6 times 6 times 6 times 6 times 6, which is going to be much greater than 2 times 2 times 2 times 3 times 3 times 3 times 3. So we don't get 6 to the seventh from multiplying 2 to the third times 3 to the fourth. In exponential form, what we get is 2 to the third times 3 to the fourth. We don't combine the bases that aren't like. If I wanted to actually multiply it out, well, I could multiply 2 times 2 times 2, which is 8, times 3 times 3 times 3 times 3, which is 81, and I would get 648. Another way to state what we've just learned is by using some variables. Let's say I had x to the power of a times x to the power of b. Well, since these two bases, x and x, are like, when we multiply them, we simply add their exponents. So x to the a plus b. In an expression like x to the third times x to the ninth, our answer is x to the 3 plus 9, and in this case, we could write x to the 12th. Okay, so if we know that we can add exponents when we're multiplying like bases, we can simplify some expressions like this, 3xy times 3x squared y. To begin with, let's think about rewriting this expression so that we can see what's all being multiplied. 3xy is just 3 times x times y, and 3 times x squared times y could be written 3 times x times y. It's important to know that there's a property of multiplication called the commutative property, which states that a times b is equal to b times a. In other words, 3 times 4 is 12, and so is 4 times 3. Well, this means, by extension, that 3 times 4 times 5 is the same as 4 times 5 times 3, or any other rearranging of these three bases being multiplied. If I multiply it in this order, 3 times 4 is 12, times 5 is 60. And if I multiply it in this order, 4 times 5 is 20, times 3 is also 60. So we can rearrange the order in which we multiply expressions. This helps us simplify the product that we're getting here. Well, if I put the two 3's next to each other and say 3 times 3, and then rearrange it so that the x's are next to each other, and so that the y's are next to each other, then it's more apparent to see that the answer is 3 times 3, or 3 squared, or I could write 9, but I'm going to leave it as an exponent, 3 squared, times x times x times x, which is x to the third, times y squared, is our answer. Let's see another example. 3x squared y to the fifth times 5x y to the sixth z can be rearranged if we put the 3 and the 5 next to each other, the x squared and the x next to each other, the y's next to each other, and the z. Our answer is 3 times 5 is 15. X squared times x, since they're like bases, I can add the exponents. Remember that this is x to the first. So I end up with x to the 2 plus 1, or x to the third. Y to the 5 plus 6, which is 11, and z. To solve the next expression, again, we can put all of the bases that are like next to each other. So I'm going to start with 2 times 3. Then all the x's next to each other. So I have x squared times x to the fourth times x. The y's next. Y to the third times y. And then z by itself. 2 times 3 then is 6. X squared times x to the fourth times x, remember that's x to the first, gives us x to the 2 plus 4 plus 1, which is 7. Y to the third times y, remember this is y to the first, gives us y to the fourth times z. In the last expression, we'll start by rearranging so that, we'll start with the 4. Then we'll take all of the a terms, a squared times a to the third, the b terms, b squared times b, and our c, and multiply them together. So we have 4, a to the fifth, b to the third, c. In order to simplify these expressions, we're applying the commutative property and our rule that multiplying exponents with like bases means to add the exponents. Well, we've talked about multiplying powers with like bases. What if we have a power to a power? Let's think about what each exponent applies to. The exponent of 4 inside the parentheses applies to the base of a. So it means a times a times a times a. The exponent outside the parentheses applies to everything inside the parentheses. So this exponent tells us, I'm going to go down here, to take what's inside the parentheses, a times a times a times a, and multiply it by itself 3 times. There's 2 and 3. So in the end, what we have is 4 a's, another 4 a's, and another 4 a's all being multiplied together. That should give us a to the 12th power. How could we have done this quicker? Well, a to the 4th raised to the 3rd gave us a to the 12th, and it seems that we just multiplied the exponent inside the parentheses with the exponent outside the parentheses. A more general rule for this would be to say, if we had an exponent in the parentheses and an exponent out of the parentheses, that the simplest form is a to the m times n. 3 examples. 2 to the 3rd raised to the 4th power. Remember, the base of an exponent is always the base right directly below it. So the exponent of this 2 is to the 3rd power. 2 times 2 times 2. When we raise that to the 4th power, we get 2 times 2 times 2 times itself 4 times. And so our answer is 2 to the 12th. 3 to the 6th squared to the 4th power can also be solved in a similar fashion. And this time I'm going to apply some of the rules that we're seeing here. 3 to the 6th to the 2nd power is 3 to the 12th. Now I can get rid of these parentheses and just write the brackets again. And 3 to the 12th to the 4th power would be 3 to the 12th times 3 to the 12th times 3 to the 12th times 3 to the 12th. So we can get 3 to the 12th times 4 equals 3 to the 48th. In the last example, -1 to the 100th power is a very common question to ask with exponents. And because we have -1, we have to picture -1 being multiplied by itself 100 times. Well, let's think if we notice a pattern. -1 times -1 equals +1, times -1 equals -1, times -1 equals +1. So if we look at the first -1, when we get to the second, our value is now +1. When we multiply by the third -1, our answer becomes -1 again. Then when we multiply by the fourth -1, -1 times -1 is +1. And so when we were on even numbers, we had positive values of 1. And we were on odd exponents, we had negative values of 1. So when we get down to the 100th, -1, we would expect the answer to be +1. So -1 to the 100th power is just +1. Okay, so let's see a few examples of exponents, of products being raised to powers. Let's start with 2x squared. Well, this exponent has a base that's directly below it, and since it's outside of the grouping symbol, this exponent says to multiply the grouping symbol, everything in here, by itself twice. 2x times 2x. Well, that gives us 2 times 2, which is 4, x times x, which is x squared. Notice the difference between that and the next example, 2x squared. In this case, the exponent refers to the number directly below it, or the base directly below it. In this case, just x. This means 2 times x, which simplifies to 2 times x squared. In the next example, we have 2 times x times y to the third in our grouping symbol, raised to the 4th power outside. Remember that the exponent always relates to the base directly below it. So in this case, we have 2 times x times y times y times y in the parentheses, raised to the 4th power, which means we have to take all of this and multiply it by itself 4 times. Well, we can rearrange this product to have 2 times 2 times 2, or 2 to the 4th, times x times x times x times x, x to the 4th, and then times y to the 3rd times y to the 3rd times y to the 3rd, which is going to give us y to the 12th. So 2 to the 4th, x to the 4th, y to the 12th, or 16 x to the 4th, y to the 12th, is the simplest form of 2xy to the 3rd to the 4th power. For the last example, I'm going to start inside the brackets. And inside the brackets, I'm going to do work inside the parentheses to begin with, just following the order of operations. So in the brackets, we have a times b to the 3rd c squared. So to begin with, I'll write a times b to the 3rd c squared. Well, that would give me b to the 6th c squared, because I just multiply each exponent inside the grouping symbol times this exponent. 3 times 2 is 6, and remember c is to the 1st power, and 1 times 2 is 2. I can do that same thing now to simplify this expression with the 5th power. I'm going to have a to the 5th, b to the 30th, c to the 10th. Remember that when we multiply powers with the same base, like a to the 4th times a to the 3rd, we can just add their exponents, a to the 7th. And when we have a power of a power, such as a to the 3rd to the 4th, then we multiply exponents, a to the 12th. This also works when we have what's called a power of a product. In this case, 2 times a times b times c to the 3rd is all being multiplied, and then we're raising it to the 3rd power. We simply multiply the exponents for each base in the parentheses, 2 to the 1st, a to the 1st, b to the 1st, and c to the 3rd. We multiply each of those exponents by 3. So we get 2 to the 1 times 3, a to the 1 times 3, b to the 1 times 3, and c to the 3 times 3. So 2 to the 3rd, a to the 3rd, b to the 3rd, c to the 9th.